Good morning and welcome to the Roland Academy Partner Webinar Series. My name is Brian Brooks and I am the Product Manager for Dental Solutions here at Roland DGA. Today we're going to have a partner webinar with Mike Webb from CIMsystem, or SUM3D as most of you know. This one is going to be covering getting the most out of your SUM3D CAM and the Roland DWX50. So today we're going to talk about 4 different topics. The first one is going to be an overview and features and functions available with the SUM3D CAM software. Next we're going to talk about milling some complex cases with a focus on hybrid abutments, which I think is a popular topic people have been asking a lot of questions about recently, so we're going to try to cover that for you. Also, we're going to talk about CAD software and what the requirements are for importing data into your CAM software. And then finally, we'll also take a look at some technical support and workflow time savings and tips and tricks. So without further ado, I would like to introduce Mike Webb from CIMsystem. Mike, thank you very much for joining us this morning, and I'll let you go ahead and take it away from here.
Thank you very much, Brian, and thank you everybody for coming today. Again, my name is Mike Webb with CIMsystem. I'm working out of the CIMsystem USA office in Louisville, Kentucky. And today we're going to show you a couple different features of the software that can help you save a little bit of time. And of course, you know, this is going to be focused around hybrid abutments as well. So you're going to get to see how to process those into the CAM software. So first of all, we'll go ahead and start out by talking about our first time-saving tip and trick, which is selecting by layer. So oftentimes, you know, whether you want to select multiple items within the disk or something along those lines, selecting by layer is a good alternative to having to go through and individually click every single item that you want to that you actually want to modify. So when you initially go for a selection, let's say that you're either selecting things to delete out of the project, you get your select items to modify window that we can see here in the center of the screen. And by default, you're going to be able to just individually go through and click each object that you want to delete. Let me go ahead and pull up the software here just so I can show you. Here's a run that I had opened up already. And what I'm going to do here is just simply show you how I could traditionally click to remove items. So click on our remove items, and I can go through here and individually click each one of these connectors, like especially on these abutments. Usually the auto placement on the abutments are a little bit off, so you're going to normally want to place your own support pins anyway. But I can select all of those and just right click on my mouse and say yes to get rid of those. Well, you know, if you've got a full puck of these to actually process, you can actually select these in tandem together without having to go through and individually click those. So again, I'm going to go up to remove items. And then instead of going through here and individually clicking each connector, I'm going to go over here to the Select by Layer button and simply click on that. And we're going to notice that there's going to be a little box that pops up on our screen. And you're going to have the actual names of the layers listed out here. So DMH is the name of the layer that pertains to the connectors. And it's also color-coded. So we see that there's 2 different DMHs here, one for green and one for red. So when I select the green, you can see that all the green connectors on the disk are selected. When I select the DMH layer that's colored red, we can see here that all of the red connectors are selected as well. We can also unselect those just by simply checking or unchecking those boxes. So once I have all those selected, I can right-click on my mouse and say yes to delete those selected surfaces. And of course, it will get rid of all of those. So that's one of the benefits behind using the selecting by layer, especially when you're working with abutments, because some of these layers can be red as an example. So just to kind of show you when we're going in here, if we were to use the select by color as an example, and we selected everything that was red, it would also select the red portions here that get blocked off for particular milling operations. So we don't necessarily want to use the select by color, but rather the select by layer is a better option to go with. And that just about covers all that we have for the selecting by layer. So the next item for potentially saving you guys a little bit of time or an additional trick to the software is we can actually import from a JPEG or a bitmap, which means you can take a picture of a disk from a top-down view. You want this to be on a black backdrop, so that way you have a clear image of the actual pieces that have been cut out of this disk. And you can import that into the software and use that as reusable stock. This is going to be beneficial for people that have either used disks in previous CAM software before they've adapted the SUM3D software, and they can't machine it on the SUM3D software because they don't have that part used stock file. This could also be of use for people that accidentally delete their stock files. So what this allows you to do is, again, take a picture of it, bring it into the software, and we'll quickly show you how that works as well. So I've again got another file here, which is named import stock from picture. So I'm just going to import that in here. All right, and from this point, I can see that I've already imported my STL files into the job. What I have to do next, or the next step, is to select my stock. Well, this particular stock, let's say that I have a stock that I've milled out of before, and I have a picture of it. You can take a picture with your smartphone, point and shoot camera. Really doesn't matter the resolution. You probably don't want to go as far as to get too high of a resolution with the DSLR. Larger photos may take longer to load, so it really is not necessary. But what we can go ahead and do is click on Select or Create Stock in Blank, just like we would as normal. We can see here it defaults to our stock used folder, stock that we've milled out of previously. So we can also see right here under the files of type, we can import a .blk file, which is the blank file. We can import a bitmap, which is an image file, or a JPEG, which is also an image file. So I'm actually going to navigate to my desktop, which is where I have the JPEG file that we're going to import. And here it is right here. It's a picture of the milled disk. And if I actually open this up, we can see here this is the picture. It's not the best quality picture, but it gets the point across to the software. What it allows us to do is the software is going to go through and capture the edges of this partially milled disk, and it's actually going to import that into the software as curves, so that way we can have something that we can mill out of. So going back to our selection window right here, we have the picture of the milled stock on the preview window. What we're going to do is simply select the file and click on Open. And the software automatically detects that this is not a BLK file. So it's going to automatically pop up this stock blank creation form, which allows us to then go in and set up some parameters that the computer is missing. So our shrinkage factor, because this is zirconia, I'm going to put in like a bogus factor of 1.224. You would get this off of the disk directly. You would specify what the thickness of the disk is. And just like when you're creating your disk normally, it's going to also tell you down here, based on the STL items that you've imported, what the minimum thickness of a disk that you're going to need. So you'll know even before you create this disk to bring it in. We've got some new option. We've got a new option here as well. It's called lot code. We'll go over that here in just a second. But I'm just going to give my disk a name. We're going to call this test. And then the lot code, this can be something for FDA traceability. So for some reason, if you if you got a call from your manufacturer saying, hey, or your zirconia disk manufacturer saying, hey, this lot was bad, we need to recall those products. It's a good thing to have this lot code because you can actually print this out on your report for your run reports, and you can use this for your traceability if for some reason you need to go back in the instance that there's something wrong with that material. We're going to leave that blank for this presentation though. So I'm just going to click on OK. And it's going to import that disk along with the curves. And it's also going to so we'll just give it a second to finish doing that. And we can see here that the disk imported, it looks like it's a little bit sideways. So that's another trick. When you're taking a picture of the disk, you want to get it. You want to get the picture of the disk in the orientation in which it's going to sit inside the machine. If it pulls in sideways like it does here, we also have the option of rotating the disk, which is this button right down here where it says rotation of the blank. Once we click on the rotation of the blank, we'll get like a dotted line that comes right down through the middle and also across through the disk. What we can now use is the plus and minus keys on our keyboard to rotate this either clockwise or counterclockwise. So I believe the position of this image when I took it was more upright or vertical like this. So once we have it where we want it to be, we simply hit the click the Enter key on our keyboard, and it's going to ask us to confirm the changes that we've made. We just say yes. And again, it's going to auto-place those items within the disk to make sure that they fit. So as that's auto-placing, what I'm going to quickly do is just show you a picture of that disk side by side with what we pulled into the software. And there we can see that it's imported those curves into the software, so we're going to be able to mill with that. One of the things, because this is going based off of a picture, we can see in some areas here where in the actual disk it milled almost all the way to the edge of that disk, but in the software it's showing that there's a gap there. And that's because it doesn't see the distinction of the black line all the way up here at the corner. So because of that, you definitely want to make sure that you take as top down of a picture as possible of this puck. But you also, when you're nesting, you want to take that into account. So in some cases here, where this bridge, as an example, is right on the part border, you may want to simply just move this bridge down just a little bit, get a little bit further away from the part that's been milled out, so that way you provide yourself with a little bit extra clearance and you don't have to worry about milling out into open space or anything like that during the process. So that's the import your stock from a picture function. And then this is the slide that basically talks about, again, if needed, you can rotate the stock for the alignment just to make that line up with the way that you took the picture. The next option is to be able to delete a group of curves. Now this is a brand new function, so if you're running on an older version of SUM3D, you may not necessarily see this button, and if you don't, when you get back home to your labs and try this out, then definitely contact your distributor. Most of these are accessible through our maintenance updates, and we'll kind of talk about the importance behind that as well. So here's the delete curves. What this button allows us to do is, if we've partially milled out of a disk and maybe it's something that we calculated in the previous run but we didn't actually run it on the machine, well, as many of you know, and for some of you that don't know, whenever you hit the calculate button in SUM3D, it actually exports your partially used stock. So if you have 6 crowns positioned in the stock and you hit calculate, it's going to save that as if you milled those out. It automatically goes under that assumption. So let's say for some reason you didn't mill it, you decided to rerun those and you want to use that same stock. Well, it's very important. What you need to do is come in here, click the delete curves, select those items, and then take them out because you didn't actually mill those out. Otherwise, you wouldn't be able to use those spots in the disk. And just quickly to show you that in the software, I can just, I'm going to start a new file here. And we'll just go with the default settings, and I'm going to import a disk. I won't bother importing any items at this point because we're not actually going to mill anything, but just to be able to show you how we can get rid of some of these items. So I'm going to use this test blank that I've created. All right, and let's say that these 3 items right here did not mill out at the top. So what I'm going to go ahead and do is simply click on the delete curves button, and that's going to pull up this new selection menu. What we can do, because we can select multiple curves, all I'm going to do is just I'm going to click on these 3 part borders of the units that I want to get rid of, and it's going to highlight those in white on the screen. All right, so what I have to do next is just right click on my mouse, and it's going to ask if I really want to delete these selective curves. So I'm going to say yes to that, and we can see that it gets rid of those curves from the project. So now, if we need to place items there, we can certainly do that because they never really milled out to begin with. So the next thing that I'd like to talk to you guys about is what files you need from the CAD software to make your life a little bit easier in the SUM3D software, especially when you're processing these in a production environment. So there's a couple different output files. 3Shape, they give you the PTS and the XML files. XMLs are going to be for the abutments. The PTS is going to be for the margin line. The ExoCAD, they output what's called a construction info file, which produces all that information as well. And Dental Wings outputs a POL file, which gives you the margin line as well. So a lot of people ask, why is the margin line important? Well, the primary reason behind that is when you're milling, the margin line is such a finite thickness that you really don't want the machine to just, for lack of a better way to put it, to just mill right over that margin or go back and forth over the margin. So you almost want to set up boundaries to keep the software, or that way the CAM software knows to take extra care when it's in this area. And that's primarily the reason why you need to capture the margin. Now, by default, most CAM softwares out there, as well as the SUM3D software, will automatically detect the margin as best as it can. Now, as many of you lab owners know, and some of you in production know, that may not always be the best detection, and primarily because when the dentist goes to prep inside the patient's mouth, he may come out with a jagged margin, and as such, when you design a restoration around a jagged margin, you're going to end up with jagged lines along the margin on that restoration. So because of that, it's a lot harder for the software to detect it. It also takes up a little bit more extra time because the software has to try and detect those. So what this does, if we use these additional files from the CAD software, it automatically tells us where you design the margin, and it takes all the legwork out of there, so the CAM software doesn't have to automatically detect it. But the more important part is you're getting the precise placement of that margin. So as some of you may know as well, you also have some milling operations that concentrate on the margin. This is where this would come into extra importance, because you want the tool to travel right along the margin. You don't want it skipping back and forth over the interior and exterior portion where you could cause chips in the milling. So those are the primary importance behind those extra files. A lot of these files you can get as part of the output options in your manufacturing output. And if you're not sure how to access those, definitely contact the reseller of your CAD software, and they should be able to tell you how to output these additional files. So you should end up with typically 2 files. If it's a crown and a bridge or any type of those simple restorations, you're going to end up with your STL file, which is just the geometrical data that's output from that software, and then you're going to end up with a PTS file or a construction info file or a .pol file, depending on your CAD software. So you're going to have those 2 different files, and all you have to do is have that either PTS file, POL file, or construction info file in the same folder as your STL when you go to import it into SUM3D, and it's going to automatically capture that data. So you'll just import your STLs like normal. The next thing that we're going to talk about are hybrid abutments, and this is what a lot of you have come here to kind of see. There's a slightly different workflow. The general workflow is the exact same, but the difference here are some of the steps that we take additional with the hybrid abutments to make sure that those get processed in a proper fashion. So the very first step that we're going to do is we're going to start a new job. This is going to be the same as what you do when you start a new job anytime. And I'll walk you through these steps that you need to perform first, and then I'll show it to you in the software just so you guys can follow along. So we start our new job. The next step would be to go ahead and import our STL files. It's very important when you import your STL files to actually choose the type of restoration that you're importing. And the reason behind that is there are certain steps in the strategy that actually look at the type of restoration it is and decide whether or not it's going to apply a particular toolpath towards that. Just as an example, you're not going to treat the milling of a coping the same way that you would treat the milling of a full contour crown, because maybe with the full contour crown you potentially have a smaller tool that's going to come in and define some more anatomical detail. So that's all built into the strategy. That all depends on the strategy that your resellers have provided you with. But you definitely, for a hybrid abutment, always want to select glue object. So once you import your STL files, the next portion is going to be to select or create your blanks. And that's, again, going to be the same as your regular process. So we haven't really deviated yet from our standard procedure. The next step is to close and check and close any of these holes that need to be closed on the hybrid abutments. Hybrid abutments have a little bit different of an interface, and they're kind of unpredictable because there's so many different libraries of hybrids out there, and the internal structure of where that cement goes and where you place the titanium interface in, those are all going to be different, going from one provider of a hybrid abutment to the next. So because of that, it can sometimes be a little bit unpredictable on how it imports into the software. And what you can do is you want to check these, and you want to make sure that these holes are closed. For normal abutments, this isn't a problem because you typically just have a cylinder that goes all the way through, and the software can see that and close it very easily. Now, the reason behind closing these holes is there are certain operations, like as an example, the roughing operation. The roughing operation, when it comes into initially with your larger tool, whether that be a 2 or a 3 millimeter tool, it's going to rough out as much as it can before it steps down to a smaller tool to be able to finish that out. Well, in certain stages of the roughing, you want that hole to be closed because you don't want the tool to go inside and rough that out yet. Maybe in the strategy you have that set up as a different operation. So it's going to rough out the outside first with that hole closed, and then as part of the next step, when it's ready to go inside, it'll get rid of those layers where the holes are closed, and it's going to tell it to go specifically just inside of that interface portion of the hybrid abutment. So that's the reason behind making sure that these holes are closed. The next step is to check the positioning of these support pins. So we're working on some more intelligent placing of these support pins, so that's something that we can look forward to in the future. But for now, the software just kind of places those in there for us. So it doesn't necessarily know not to place those right on the margin, right above the emergence profile of the abutment. So what we want to do is we want to check that, and for areas that we can see up above here in the top right-hand screenshot, we would want to delete those connectors out and replace those ourselves. And we'll kind of talk about the placement of that as I'm going through the software and showing that to you as well. The next step is to, of course, calculate it and send it to the machine. So this is the same as the process with any other case. The only differences that you have with your hybrid abutments is you're going to check and close any of those holes before you mill them, and you also want to check the positioning of the support pins. Okay, so let's go ahead and go over to the software, and I'll just show you quickly. I'm going to import one of those hybrid abutments and just show you my workflow with one. So I'm going to start with my new file, and I'm just going to leave this default. Select my material, select my machine. I've got that already taken care of, and hit save. And we see we have the new CAM file here. The newer versions of your SUM3D software, you may notice as well, as long as you're in a medium level interface or lower, it's going to walk you through this process. So these windows are popping up. I'm not having to click these. They're automatically taking me through those steps. So I'm going to go over to abutments here, and I've got quite a few. I'm just going to select the one and click on glue object. So now that I've clicked on glue object, I'm going to click on open, and it's going to import that abutment for me. Okay, we also get a little prompt after it's imported in the newer versions of SUM3D that asks if we want to import more objects. For this particular case, I'm just dealing with the one, so I'm going to select no. And it's also told me that the milling stock has not been defined. Would you like to select the milling stock? I'm going to select yes. And I'm going to use just one of these test blanks that I have from the system that I've been using from before. So I'm just going to select open. All right, and it's imported, auto-placed that particular abutment. Now it's asking me if I want to run the machining calculation. At this point, I'm going to say no, because I want to, one, I need to check these holes, make sure that the holes are closed properly, and two, I need to check the support pins. So I'm going to say no. And we can obviously see here, just looking at it from a quick glance, that the placement of this support pin isn't necessarily ideal. So we're going to want to probably get rid of these support pins and then come in here and replace these manually. So I'm just going to go to my delete items or remove items. I'm going to do that select layer, and I'll just get rid of all of my connectors. And now my connectors are gone. Now I'm free to come in here and place my own support pins. So just like normal, I'm going to click on Add Support Pins. And we have our starting diameter and ending diameter. The starting diameter is the diameter of this pin at the part. So if we wanted this to taper down, I could actually set my ending diameter to maybe like a 3, just as an example. And that's actually going to start at a 3 millimeter diameter from the stock and taper down to a 2 millimeter diameter on the part. It's not necessary. You can usually go with the 2, but it just depends on what your preferences are for placing your support pins. So what I'm doing now is I'm just simply rotating it to get a better angle. And what I would typically suggest, and you know, opinions are going to vary on this, but from what I've found from a milling standpoint, it's always better to place your support pin in the subgingival area on an abutment. And the primary reason behind that is if you were to place it above this margin line right here, you're going to end up with an undercut to where the tool can't get between the support pin and the margin area. So all this area right here underneath the support pin is going to be left as raw stock. And you don't want that, because then you're going to have to be touching it up after it's come out off the mill in the green state. You know, it could potentially ruin the margin that you had defined in the CAD software. So I'm going to get rid of that connector that I had created above it. And I'm going to create one more connector on the opposite side. Now, sometimes you may see that the fixture gets in the way, and if it does, you can simply make it transparent or get rid of it from the view. And that's down here in the bottom right-hand corner. You can click on the fixture, and I'm going to set this to transparency. So that way I can just simply see right through the fixture. So now I'm going to go ahead and add my support pin, the additional one here. And again, we're placing that in the subgingival area just to make it easier to mill out that margin line without any type of distortion. Now, if you don't have very much subgingival area, you know, if it's like a tissue level implant, then one of the, you know, you may have no other choice than to place it on the top cap portion above the margin line. And if that's the case, you know, that's how you've got to deal with it. But as much as possible, you want to place it subgingival. Okay, so I've got my support pin set up for this particular abutment. The next step that I need to do is check the underside. So I can quickly go to my bottom view by clicking on the bottom view at the top. And that's going to show me the bottom of the abutment. So as I zoom in here, I can clearly see that the hole is not completely closed. And again, this is going to be common behavior to see on hybrid abutments. So what I want to do is, down here at the bottom, there's a holes closing option that I want to click on. When I click on that, I simply click on, what you're looking for is a change in the contour of the surface. So if it's an abrupt change, it's going to be easier, and you can see that by this black line that's kind of going around the bottom of the abutment. I'll simply click on that, and we can see that the hole's closed for us. So again, this is really mostly used when you're roughing out the abutment, but it keeps the tool in check. In certain operations, it's not going to send the tool in there during the roughing stage to potentially, you know, cut that area out when we don't want it to. Okay, so that's pretty much the only steps that you do that are different in the abutments. What I would do at this point in time is just go ahead and start my calculation for the machining process. And this is going to, the selection that you get here is going to differ based on your reseller and what they've provided you in your strategy. So one of the more important things that you definitely want to check out with your distributor before you try milling this is you want to make sure that they've actually incorporated the hybrid abutment milling capability into the software. If they haven't done so yet, when you import it, it may not even apply the correct tool paths, or it may not even calculate at all. So that's very important. Also, if it's not showing up under the selection menu, it could also be regulated because your reseller is testing that functionality first before they get it out to you. So definitely check with them before you try milling any of this. Whenever you're milling a new object type in SUM3D, something that you've never milled before, especially if it's something that you're not sure that your reseller has provided you with, what I would do after your calculation, instead of sending it directly to the machine, when you get that option, I would say no to send it directly to the machine, and then I would go ahead and run through the simulation to make sure that it's cutting out correctly. This should be the general workflow whenever you're milling out anything new that you've never really milled out before, just to kind of give it a check. I mean, certainly it doesn't hurt to simulate after every run, but of course, in some production environments, we all know that that may not necessarily be possible. So we can see that the toolpath is going through here and calculating this object for us. The difference between regular hybrid abutments and screw retained crowns is, in terms of the processing, it's going to be all the same. So that's basically all that there is to the actual processing of a hybrid abutment. So what I'm going to go ahead and do now is talk a little bit more about CAM software updates and how this impacts you. Why is this important? As an end user of the software, this is very important to you. At least I would hope so. When you're in a production environment, you want access to the newest features of the software that help make you a little bit more productive. So some of these features that I've shown you, if you get back to your version of SUM3D, you may want to check the version and make sure that you're up to date. If you're not up to date, check with your reseller or your distributor of the software, and they can typically get you up to date. Now, there are maintenance costs that are associated with the software. As many of you know, when you buy SUM3D, you're not forced to purchase this upgrade, but as a perk, whenever you do purchase that, you get access to these new features and bug fixes and things like that. A lot of that is also increased stability with the software. So, we release at CIMsystem, we release on sometimes a daily basis new fixes to the software to be able to get either issues from distributors' standpoint fixed, or we can get issues from an end user standpoint fixed as well. So as issues come up, definitely communicate those over to your reseller, and those will be a good conduit of information back to us. But when you pay for that maintenance update, it doesn't only just get you new features in the software, but it also gets you fixes to older problems, as well as better functionality within the software in terms of processing times and things along those lines.
I think that is going to wrap it up for us today. We're just about out of time here. So I want to thank you again, Mike, for joining us today. I think we're going to be, we can probably count on making this a series where we can get into some more complicated features of both the SUM3D with the Roland DWX50. Down the road, we can talk about the new DWX4 as well, the SUM3D software that supports that machine. Everybody can, you've got Mike's contact information. If you don't have mine, it's bbrooks@rolandega.com. You can also contact our technical support group anytime. I want to wish everybody a very happy holidays and a happy new year. This will be our last webinar of 2013, but please stay tuned for webinars coming up next year. Probably going to increase the amount of webinars we do, especially with our great partners like SUM3D. So once again, thank you very much, Mike, and everybody have a wonderful new year, and we'll see you in 2014. Thank you very much. Bye-bye.